we now come to Newton's third law. And Newton's third law you actually probably know in a more colloquial form. For every action there's an equal and opposite reaction. Now in physics we actually don't use the word action, we use the word force. So a colloquial way in a physics class of saying Newton's third law is for every force there's an equal and opposite force. But for that to be a little bit more concrete, we need to make it even a little bit more specialized than that. So this is a good working definition of Newton's third law. And it states that if object A exerts a force on object B, then object B exerts an equal force on object A in the opposite direction. Right? So if I have two objects, one of them exerting a force on each other, the other object is going to exert an equal and opposite force on the first object. For instance, if you are pushing a chair across a floor, you are pushing on the chair, therefore you're putting a force on the chair. The chair is actually putting a force back on you in the equal amount that you're pushing it. So we will come to a potential stumbling block that a lot of people have. If the chair's pushing back on me with exactly the same force that I'm pushing on it, why am I able to push it across the floor? Okay, we'll address that before too long, but a more popular way to demonstrate the third law and demonstrate the validity of the third law is with the idea of a rocket, all right? So let's say we have our rocket here, and we have our fuel tank, and here we have the engine, and the engine is where the combustion happens, and it expels the gas. And so what is happening is the engine is expelling the gas downward. It's pushing the exhaust downward. So it pushes the fuel downward, right? And because the fuel is being pushed downward, that means the fuel, as it's being pushed downward, is pushing up on the rocket. So the rocket is being pushed upward. So the fuel pushes the rocket in the upward direction. And that's how a rocket is able to fly in space. Shouldn't really use the word fly. That's how it's able to move in space. And there's a common misconception that because there's no gravity in space, then a rocket shouldn't be able to work because the rocket has to push against gravity. That's a common misconception. It is completely due to the third law. If I expel something downward, then it will cause the other, the object that's causing the expelling to move forward. You can do the same thing with a balloon. If you blow up a balloon and you fill it with air and then you let the air out, as the air is being pushed out of the balloon is pushing the air out. The air being pushed out is going to push the balloon forward. That's what causes it to fly around. You can actually tape a straw to the balloon and put some string through the balloon and cause it to fly in a single direction, and that's always fun. But the principle is exactly the same. Okay, so you don't need gravity to push for rocketry to work. It is completely due to the third law. In the next video, we will start to explore Newton's second law again with a few more robust examples than what we've done before.